Today we are going to learn permutations and combinations. But before that, I'd like to introduce myself. My name is Kumar and I'm taking today this permutations and combinations. This is a most general topic, we can say. It's a general topic which can be taught even to a common man who can calculate all the problems in this one without the knowledge of any engineering subject. Like further, this is such a topic which will come throughout your career, like even if you go for any competitive examinations also, it will come. So before entering into the topic permutations and combinations, and let me first explain you what is the principle of counting. You can see that slide there, and the principle of counting, you can see this is if an operation can be performed in A different ways independently, second operation can be performed in B different ways independently, and third operation can be performed in C different ways independently, and so on and so on. Then all these operations, one after the other or simultaneously, can be performed in A into B into C into and so on different ways. That is the definition of principle of counting. So similarly, if you see the second part of that slide there, similarly either of these operations can be performed in A plus B plus C plus and so on different ways. So what does it mean? What is the meaning of an operation? You know, the operation, for the purpose of definition, it is named as operation. Operation is nothing but the day-to-day works which we take up is termed as operation here. So let us see an example to better understand the definition here. So let us see the example now. If you see here in the next slide, the principle of counting, yes, example 1, that is, if there are 18 railway stations on a railway line, then how many second class railway tickets are to be printed that enables a passenger to travel from one station to another? Please go through the question carefully. If there are 18 railway stations on a railway line, then how many second class tickets are to be printed that enables a passenger to travel from one station to another? If you go through the problem carefully, the general thinking you must have is this. If you go to the railway station and if you take a railway ticket, for example, you are traveling from Hyderabad to Nagpur, let me say. So then you'll go to the railway station and you'll ask for a ticket in the counter. Then a ticket will be given, and on that ticket you will have the two stations printed like this. It is Hyderabad to Nagpur. Hyderabad to Nagpur, let me say NGP, HYD stands for Hyderabad. Now, the railway people, for example, you have become or you have become a railway official, and you have to count how many number of tickets are to be printed for the passenger to travel on all these 18 railway stations. Then you must have the basic knowledge of this principle of counting. Then when you take this ticket on the ticket you can see that there are 2 stations printed here, and in the problem given, how many stations do you have there? You have totally 18 stations. Among 18 stations, Hyderabad and Nagpur also two stations are in these 2 stations are included in the 18 stations. So in the first place, how many stations can be printed? In the first place, how many stations can be printed? That is, from Hyderabad to Nagpur, the ticket is given. Then in the first place, you can print any one of these 18 stations given. Any one of these 18 stations given. For example, from Hyderabad, you will reach to some Nagar, or we will reach to Warangal, then Nagar, then Balarsha, then Nagpur. Like that, all those stations can be printed here. So in how many ways the first operation of printing the first station can be done? Printing the first station can be done in how many different ways? It can be done in 18 different ways. Understand it? 18 different ways. So if one station is already printed, then how many stations are remaining that are to be printed in the second box? Because one station is already occupying the first place, the remaining stations are to be printed in the second place. How many are they? Remaining are 17. Then you may think, sir, why not it is 18? Or you can understand that you never take a ticket from Hyderabad to Hyderabad. That is why when you take any ticket, the 2 stations will be different and it will not be same. So when one station is occupying already one place, that station is to be eliminated in the second place. So here, in the principle of counting, the first operation of printing the station in the first place can be performed in 18 different ways. 18 different ways. And the second operation can be done in 17 different ways. So these 2 operations, one after the other or simultaneously, can be performed in 18 into 17 different ways. You can count it, of course. 8 sevens, 6, 1, plus 2. So the number of second class railway tickets that are to be printed are 18 into 17, that is 306 number of tickets are to be printed in this case. So performing the first operation can be done in 18 ways. Second operation can be done in 17 different ways. These 2 operations, one after the other or simultaneously, can be performed in 18 into 17 different ways. Okay. Similarly, if you go to the second example, Mr. Rahul has 5 different colored trousers, 7 different colored shirts, and 3 different colored blazers to wear. How many, number 1, different colored triads he can wear in the same order? So what does it mean? You can see the problem carefully. Please go to the problem once carefully. That is, number of trousers or 5. Trousers are nothing but pants, I can say. And number of shirts or 7. And number of blazers or 3. Now, number of how many different colored triads he can wear in the same order. In the same order means first a trouser, then shirt, again on that one blazer. That is the order. This is triad. I termed it as triad. So in how many ways it can be done? And you can see how many trousers are there. Let me say trouser for the better understanding. T1, T2, and it is T3, T4, T5. And shirts S1, S2, S3, S4, S5, S6 and S7. These are the shirts. And blazers B1, B2 and B3. Now let us start from the first trouser and first shirt. So he's wearing the first trouser on that one. First shirt he's wearing. Then for this combination, how many blazers he can wear? Number 1, number 2 and number 3. So for the first trouser and first shirt, he has 3 blazers to wear. That means it can be performed in 1 into 1 into 3 different ways. Similarly, for the same trouser, he can shift to the second shirt, and for the second shirt also, again he has 3 ways to go with the blazers. So again it is also 1 into, this is 1 into, again 3 ways. So 1 into 3. So how many will get like that? So for this trouser 1, that is first pant, he has 7 shirts. Again for each shirt he has 3 blazers. So he will get 7 such type of different combinations in this case. 1 into 1 into 3 plus 1 into 1 into 3 plus so on. How many times? 7 times he will get. So it will be nothing but for first pant. This is for first pant. He has how many? 1 into 1 into 3, 1 into 1 into 3, 1 into 1 into 3, so on 7 times. So it is 1 into 7 into 3. These are added 7 times. So for the first pant, he has 7 into 3 combinations. You can understand. For the first pant, he has 7 into 3 combinations. And for the second also, same. For the third also, same. For the fourth also, same. For the fifth also, same. So it will be added how many times? 1 into 7 into 3 plus 1 into 7 into 3 plus and so on. How many times? 5 times. So it should be like 5 into 7 into 3. Understand it? So the first operation is nothing but the wearing the trouser here, and second operation wearing the shirt, and third operation wearing the blazer on it. So and all these can be simultaneously done in how many different ways? 5 into 7 into 3, which is nothing but this is 35 into 3, which is nothing but 105. That means with these 5 trousers, 7 shirts, 3 blazers, he can create 105 different combinations. 105 different combinations. So this is a better example to understand the principle of counting. The first operation can be performed in 5 different ways. Second operation can be performed in 7 different ways. Wearing the blazer can be performed in 3 different ways. So all these can be simultaneously done in 5 into 7 into 3, which is nothing but 105 different ways. Now, coming to the next question, please go through that. How many ways he can wear either trouser or shirt or blazer? Either trouser or shirt or blazer. This is and. Trouser and shirt and blazer. But the second case, if you see that, it is either trouser or shirt or blazer. Okay, so now the first operation of wearing the trouser can be done in how many different ways? It can be done, you can see, in 5 different ways. It is 5 only. Either this or this, that is, or shirt can be done in 7 different ways, and blazer can be wear in how many different ways? 3 different ways. So either this or that or this can be done in 5 plus 7 plus 3 different ways, which is nothing but 15. Find the difference here. Very basic thing where the students generally used to ask the questions like this. Why should we add? and why should we multiply? Understand it clearly. And in the previous case we have multiplied, in this case we have added. The reason you understand it, come to the previous slide please. Please note that, please note, if you go through the please note, and stands for multiplication or intersection. Further, after the introduction of set theory, understand it, wherever you get and, instead of and, you have to write into multiplication, and instead of into you will have to use intersection, or intersection can be written as into multiplication and into can be written as the and. So there is no difference between these three in permutations and combinations. Understand, whenever you come across and in the problems, multiply or use intersection. Whenever you get intersection, use into, that is multiplication. Similarly, if you have R here, if you see that R stands for addition, addition means plus, and that plus after the introduction of set theory, and that you will be learning the probability based on these permutations and combinations. In the probability, this union will be converted as addition plus, this plus is nothing but R. So no confusion while solving the problems where to use multiplication and where to use addition, simply based on this. So and into intersection, R plus union. This is a very important point to be noted while working out the problems. Okay, so now today what we do to get more confidence in working out the problems, first of all, we will learn the basic problems that can be solved only on the basis of principle of counting. So how do you analyze the problem? Mainly in solving the problems of permutations and combination, and further in probability also, the approach in solving the problem is very, very important. So here also, whenever a problem is given, your approach in solving the problem should always be like this. You will feel the problem easy when you separate the operations. And separate the operations means what we did in the previous examples, we have separated the operations. What are the operations there? In case of tickets, what we did, we applied our general knowledge. What is the general knowledge? General thinking. Everybody knows that when you go to a railway station, you will take a ticket. On the ticket, you must know, you all know that you will find only 2 stations on the ticket printed. So how do you proceed? We have considered the 2 places there, 2 blank places. That is the approach. That's very important. So in these blank places, then we will think. How do we think? How this blank place can be filled? How many stations are given in the previous example? 18 stations are given. That is why we filled it 18, and the remaining in 17. Then why not 18? Then it is also common sense. What is a common sense? We never take a ticket from Hyderabad to Hyderabad, or Nagpur to Nagpur, or Delhi to Delhi. We never take. That is why it should not be repeated. So that station which is filled already in the first blank place should be eliminated here. First operation, second operation. We have split the operations like that. Similarly, in case of the trousers, shirts and blazers also, we have separated the operations. So whenever you solve any problem that is when you are solving any problem related to permutations and combinations, or further in probability also, first of all separate the operations and then proceed to principle of counting, or whatever the permutation or combination further we are learning, you apply them. Okay, now let us see some basic simple problems based on this principle of counting. Okay, now the first question here, you can see, find the total number of 8-digit numbers that can be formed. Very simple question. Nothing is given. A single sentence, you can say, find the total number of 8-digit numbers that can be formed. Then what must be your thinking? 8-digit number means it will contain always 8 blank places. 8 places will always be there. 1, 2, 3, 4, 5, 6, 7, 8. Now in these places, the digits will be present. You know that. It is ones place, tens place, hundreds place, thousands place, 10,000 place, and so on like that. Okay, and digits will be present in this one. Now what the question is, here you need the total number of 8-digit numbers that can be formed. So what are the digits we have in our hand? Nothing is mentioned in the question. So you have to take all the digits that we know. What are the digits we know? It is 0 to 9. How many are there from 0 to 9? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 digits are there in our hand now. Now these 10 digits only to be used to fill these places. It's common sense. You can understand that. So in that case, the common thinking must be like this. This blank place can be filled in 10 different ways if I say. Then immediately you must object. Why? Sir, in the question it is given that we need an 8-digit number in these 10 digits. If I fill 0, then it will not be 8-digit number, but it will become a 7-digit number. Absolutely right. So your thinking must start there. So 0 should not be filled here, because if you fill 0, what happens? That will become a 7-digit number. So 10 digits should not be filled. Then in such a case, 0 should be avoided. So I will fill it only in 9 different ways. 9 different ways. By avoiding 0. I'll avoid 0 here. That is why I put an into mark here for a better understanding that 0 is avoided in this case. Now, coming to the second place, there is no objection at all. You can write 0 here. So how many digits are there in your hand? There are 10 digits. Here also 10 digits. Here also 10 digits. Here also 10, here also 10, here also 10, here also 10. Then you will be thinking in this way. You may be thinking in this way also. Like, sir, when one digit is already occupied, why are you using that digit here? Nothing is mentioned in the question, I say. Nothing is mentioned. If you are asked to find out a 8-digit number that contains different digits, then you have to fill like that. But nothing is mentioned here. We need 8-digit numbers. So that is why repetition is also allowed. That's what I mean to say here. And if the same question is, I'll alter that question and I'll discuss with you now. But before that, let us finish up this first. So because 0 is not allowed in the first blank place, if you fill 0 here, it will become a 7-digit number, but not an 8-digit number. That is why that is avoided, and only 9 chances are there. The first operation can be performed in only 9 different ways. Second, 10 different ways. Third, 10 different ways. Fourth, also 10 different ways. All these operations, one after the other, or simultaneously. All these operations, one after the other, or simultaneously, can be performed in how many different ways? 9 into 10 into 10 into 10 into 10 into 10 into 10. So, the number of 8-digit numbers that can be formed or that are present is nothing but 9 into 10 power 7. These many 8-digit numbers will be there. So you can see the answer also, that is 9 into 10 to the power 7. So that is the answer. So let us not limit ourselves to this one only. Now let us discuss. Among all these 8-digit numbers, how many are even numbers and how many are odd numbers? how many are even numbers and how many are odd numbers. Let us see that. Then you are the better judge to decide that how many even numbers will be there, how many odd numbers will be there. If I write 0 to 9 digits, 0 to 9 digits, then among this, how many are even, how many are odd? You know that. This is even, that is 5 digits are even and 5 digits are odd. That means all these digits, you can understand, they are equal in number, 5 even, 5 odd. Then what I'll do like this. What I need now, number of even numbers above, number of even numbers above. We need that. So what I'm doing, first I'll fit 0 here. I'm avoiding this because my even number or odd number depends on this place. If this place contains a number which is divisible by 2, then you can say that it is an even number. So I can fill this place either with 0 or with 2 or with 4 or with 6 or with 8. Understand it please carefully. Then what happens? If you need the number of even numbers in this case, then this blank place should be filled only with any one of these 5, but not 10. If you fill it with 10, then what happens? The total number of 8-digit numbers you will get, but I need only number of even numbers. That is why I am filling it with only 5 different ways. The number of even numbers will be, then in this case will be, what happens? It is 9 into 5, 45. And how many tens are remaining now? 1, 2, 3, 4, 5, 6 tens are remaining. So 45 into 10 power 6. Understand? So the number of even numbers in this case are 45 into 10 power 6. Similarly, number of odd numbers also same. It will be equal. Understand that. It will be equal. If you add 45 into 10 power 6 and again 45 into 10 power 6, you will be getting this. So half of them are even, half of them are odd. Just I want to tell you how that principle of counting can be used in this case. You understand it. So that changes according to the need. Here you need an even number, that is why it is filled with 5 ways, and if you need an odd number also, it should be filled with 5 ways. And you will be getting some questions like this. What should be the how many numbers will be there? Whose sum is even? The digits that are present in these places, if you add the digits, the sum should be even and the sum should be odd. Then in that case also the same answer. Think of it. How is it? Think of it. You can understand easily based on this. Okay, so coming to the next question. Find the number of quadratic expressions that can be formed with the coefficients from the set 0, 1, 2, 3. How many of these touch x-axis if shown on the graph? So this is a very simple question, you can understand. But before that, what the algebraic knowledge you must have. What is the question there? Find the number of quadratic expressions. So when you come to quadratic expressions, if I ask you the question, what is the standard form to the quadratic expression? You can think, you can say, everybody says that it is ax square plus bx plus c. Everybody says that, but very few say that where a not equal to 0. It's a previous question, I say. And these are small things we generally neglect, where the questions will be formed based on such type of small things. So ax square plus bx plus c, understand whenever the question is asked what is the standard form to the quadratic expression, the leading coefficient should not be 0. So the standard form to the quadratic expression is ax square plus bx plus c. And so what is a set now given? The set given now is 0, 1, 2, 3. So how many digits do you have here? 4 digits you have. And how many places you have here? Those numbers are to be given to ABC. That means in place of A, you have to write either 0 or 1 or 2 or 3. That means what? Here, as I already told you that A is not equal to 0, it should be filled only in 3 different ways. Understand? Which is very important thing. And B can be filled with any one of these 4 digits. So it can be filled in 4 different ways, and C can also be filled in 4 different ways. So the first operation we have performed in 3 different ways, second operation we performed in 4 different ways, third operation we performed in 4 different ways. All these operations, one after the other or simultaneously, can be performed in 3 into 4 different ways, which is nothing but 48. So what you understand here, 48 different quadratic expressions can be formed using the digits 0, 1, 2, 3. So how they will be? Let us suppose A1, 1 into x square, B also 1, let me say x, C also 1, let me say 1. That means in this case what I did, in this case, what we did, A is equal to B is equal to C is equal to 1. I have taken an example. So, it is a quadratic expression. Understand? Similarly, A1, B2, that is 2x, C1. In this case, what I did, A1, B2, C1. Now, if you see this carefully, the question given there is how many of these touch x-axis if shown on the graph. So, you all know the graph of a quadratic expression. It is from the lower classes itself, from your 10th class itself, you have learned the standard form of this quadratic expression. If you take it as fx, or if you take it as y is equal to fx is equal to x square plus x plus 1, and if you show this on the graph, if you put x equal to 0, then it is 1. X equal to 0, it is 1 somewhere, it will cut here. And if you see the discriminant, you know the discriminant for this one, all of you know, b square minus 4ac is nothing but 1 minus 4 is less than 0. Its discriminant is negative. That means it doesn't have any real roots. Doesn't have any real roots means it never cuts x-axis. Why shouldn't it cut x-axis? Because if it has any real roots, it will cut x-axis. If not, it will not cut x-axis. That is why it will be something like that. So, which is not our required expression. So, let us come to the second case now. This is x square plus 2x plus 1. Then, x plus 1 whole square. This is, you can understand that it is nothing but x plus 1 whole square. If you see the discriminant of it, what is the discriminant? B square 4 minus 4 into 1 into 1, 0. 4 minus 4, 0. That means it will have roots but equal roots. So, what are the, where does it touch x-axis? So, if you If you see this carefully, when the discriminant becomes 0, if the roots are equal, what are the roots in this case now? Minus 1, minus 1. You can see that. X plus 1 whole square is equal to 0. If you equate, then minus 1, minus 1. So it will go, if you put x equal to 0, it is 1. It will go like this. So in this case, what we require is how many such quadratic expressions will be there when shown on the graph touches x-axis. This is our question here. You have got one such combination. So for that purpose, what should be our approach? Just for the understanding sake, I have explained you, that is, in this case no real roots, in this case equal roots, or rather coincided roots. And if you say, if it is like this, then in this case you will have two real roots. So now how many such expressions will be there which contains its graph touching x-axis? Then you consider b square, you consider 4ac. B square means, b square, if it is 0, can be 1, 1, 2 square, 4, 3 square, 9. Now understand, when it is 0, here b square minus 4ac, for whatever the value of 4ac it is, it will always be less than 0. B square 1, b square 1, you must have here either a1 and c0. If a1 c0, what happens? It is 1 minus 0, 1 minus 0. Then you will not have any such, that is, if you count b square minus 480, it is 1 minus 0, it is 1. It is 1. It is not equal to 0. So in our case, we require b square minus 4ac equal to 0. So it is less than 0, it is greater than 0. Now in this case, if you see, this is, if you put a1, c also 1, then b square minus 4ac, that is 4 minus 4, becomes 0. And for 9, you don't get any 4ac values to make it 0, because 4 is multiplying ac, you will never get this odd number. That is why in this case also you will not have any such equal b square minus 4ac equal to 0. So if you go on counting like that, so you will get minimum of how many you will be getting, you can understand. So in this case it is, please.
Yeah, this above question, sir. A square plus b plus c.
Okay. In this case,
B and C can be filled in 4p2 ways.
B and C can be
Filled in 4p2 ways using permutations and combinations. Permutations.
Now we are today discussing now principle of counting. What is your doubt exactly in this one? Because I explained that A can be filled in 3 different ways, and because A is not equal to 0, we can choose 1 or 2 or 3, and B can be filled in
3 ways, okay.
4 different ways, C can be filled in 4 different ways. So all these operations can be performed in 3 into 4 into 4 different ways. You first of all, you avoid permutation. We will be deriving the formula for permutation basing on principle of counting only. So in this case, do you have any doubt in this one, 48?
Okay. No, sir. No.
Okay. So
okay, just calculate in another way. So I got this.
You are saying that it is 4p2, no? We'll be coming to that. We'll be coming to that.
Can fill in 4p2.
No. 4p2. What is its value? 4p2 is 4 into 3.
4 into 3.
No, it's wrong. No?
Yeah, then
Here it is. What you're doing is you are not repeating. That means you understand. 4p2 is nothing but 4 into 3. Why 3 reduced here? Because repetition not allowed in this case. But you don't have any such case here. Repetition is allowed. So this is like that. So this permutation is without repetition. I am not talking about the repetition or without repetition, anything like that. Without repetition case, we use permutation. We'll be getting that later. Okay, you can count like this, and you can see the number of such expressions which touch x-axis will be counted in this way, wherein you take the combinations. I have already shown you a combination like B is equal to 2, A is equal to 1, C is equal to 1. So in this case, B square minus 4AC becomes 0. So what should be this expression? X square plus 2x plus 1. You count such type of expressions, and how many such expressions will be there touching x-axis. Just you see that one. So come to the next question. Next question, find the number of 4-digit numbers that can be formed using the digits 0, 1, 2, 3, 4, 5 that are divisible by 3. Now what just now the student asked a question, he is just thinking in a different way, like learning permutations and combinations should be done carefully. Now I never mentioned anything in the question that repetition allowed, repetition not allowed, nothing is given. Then you have to take the repetition allowed. If I mention separately that there should be different digits for ABC, there should be different digits for ABC, then what he is saying can be followed. But avoid that method, but first of all think most generally using the principle of counting. Most generally. After that, we will go to the turn to the formula. So never see the problem in the formula manner. General thinking is very important here. Now you can see this question now. Find the number of 4-digit numbers that can be formed using the digits 0, 1, 2, 3, 4, 5. That are divisible by 3. Now in this case, I never mentioned that the repetition of digits is allowed, the repetition of digits not allowed. Nothing is mentioned in the question. So I will take the repetition allowed. So for this purpose, if you go through the divisibility rules, divisibility rule for 2, as you know, if the first place, that is ones place of any number is like 0, 2, 4, 6, 8, then the entire number will be divisible by 2. You know the divisibility rule for 2. Similarly, what is the divisibility rule for 3? A number is divisible by 3 if the sum of the digits is divisible by 3. 1 plus 2 plus 3 is equal to 6. Then this number is divisible by 3. That we know. But in this question, you have 4-digit numbers. How many such combinations we can write in this case? Using the digits, 6 digits are given 0 to 5. It's not possible practically to count like this. And this is to be followed only when the repetition not allowed. When the repetition is allowed, or when the repetition is to be taken into account, then what should be the method to be followed? So follow this carefully. It is little tricky. So follow this. 0, 1, 2, 3, 4, 5. I have taken 6 digits here, 0 to 5. Then if I write them consecutively, how many of these digits are directly divisible by 3? 0, 3. Do you accept this? You have to. You write any 6 consecutive numbers. Among them, definitely you will be finding 2 numbers definitely divisible by 3. For example, let me write 1 here. 1, 1, 1, 1, 1. You will accept that. These are consecutive numbers. Among them, how many are divisible by 3? It's clear that it is 12 is divisible by 3 and 15 also divisible by 3. So in the first case of writing one-digit numbers, you got two numbers divisible by 3. In two-digit number also, you got two numbers divisible by 3. And you give another number, whatever you like, but it should be consecutive. If you say this one, this is 3 plus 1, 4 plus 4, 8, not divisible. 6 plus 3, 9. It is divisible again. It is divisible again. And if you say this one, 3 plus 1, 4 plus 2, 6, it is divisible again. That means whatever the fillings you do here, all those numbers can be consecutively written. Means what? They can be written in the ascending order of magnitude. They can be written in the ascending order of magnitude. That is, in other words, I can say whatever let us forget about 3. Divisibility of 3. Let us fill this. First blank place should not be filled with 0. You know that? Because this becomes a 3 distinct numbers. That is why I can fill it with 5 in 5 different ways. That is 1 or 2 or 3 or 4 or 5. And this 0 allowed here. So you will have 6 here. You will have 6 here. You will have 6 also here. That means these many 4-digit numbers can be formed using these digits. These many 4-digit numbers can be formed using the digits. How many are there? 216 into 5. 30, 80, 10, 8, 10. 216 into 5. 1080 will be there. 1080. What are these? These are the all 4-digit numbers that can be formed using only the digits 0, 1, 2, 3, 4, 5. Using only the digits 0, 1, 2, 3, 4, 5. But we need those numbers that are divisible by 3. Understand it carefully. So we have to extract the number of numbers that are divisible by 3. Understand it? That's why I've been explaining you 0, 1, 2, 3, 4, 5. And in this case, 0 and 3, only 2 are divisible by 3. Similarly, whatever the number you write, whatever it is, it should be consecutive. 6, 4, 2, 1, 2, 1, 2. 6, 4, 2, 1, 2, 1. Whatever the bigger number you take. Whatever the bigger number you take. Among this, how many are these? 5. 0, 1, 2, 3, 4, 5. 2, 1, 0 and 1 is missing here. 6, 4, 2, 1, 2, 1. 6, 4, 2, 1, 2, 1. Among these also, you will get exactly only 2 numbers that are divisible by 3. Understand? Here in this case, 4-digit number you need. So let us limit ourselves to 4-digit number. Limit ourselves to only 4-digit number. Then in this case also you can say this is not divisible by 3 because its sum is 4. In this case, 3 plus 2, 5. It's not also divisible. And if you see this is divisible. And similarly, this is also divisible. If first is divisible, obviously 6th one will also be divisible. So you will get only 2 places here, understand? You get only 2 places here. So in this case, what happens? This is 36 into 10. It is 360. And we have got 1080 there. If you take all the numbers, they are 1080. Among 1080, 360 numbers will be divisible by 3. So the answer given is to be 5 into 6 into 6 into 2, which is nothing but 360. So divisibility rule, you can follow this. This is a problem to be understood. And if the repetition is not allowed, you have to choose such combinations where the sum will be divisible by 3. Like if you take 1, 2, 3, 4, it is 3 plus 3, 6 plus 4, 10. Not divisible. So if you take some 1, 2, 3, 5, 8, 11, not divisible. Then you have to choose such a combination where it is divisible. So you can take 1, 3, 4, 8 plus, if you write this one also, 9 plus 4, 13, not also divisible. So you take 2, 3, 4, 5, 4, 9, 9, 0. You can write this. This is divisible by 3. Then in such a case, we have to internally arrange them. We will see those models after learning permutations. Okay, so this is about the divisibility using simply the principle of counting. The next question, the number of ways of wearing 6 different rings to 5 fingers in a hand. It's a most general question. It's a most general question. It's a very easy question, very basic question. Understand the number of ways of wearing 6 different rings to 5 fingers in a hand. 6 different rings are there. We have taken one ring and it can be worn to this finger or this finger or this finger or this finger or this finger. So, first ring can be placed in 5 different ways. Similarly, second ring also can be worn in how many different ways? 5 different ways. Third also 5, fourth also 5, fifth also 5. And how many rings are there? 6 rings are there. 6 rings are there. Sixth also 5. Then you may get doubt that, sir, how can we wear 2 rings or 3 rings, 4 rings to a single finger? Nothing is mentioned in the problem. It's no repetition, nothing is mentioned in the problem. So you can see some people wearing many rings also. So you can, so according to mathematics, how many different ways those 6 rings can be worn to these 5 fingers is first operation 5 different ways, second operation 5 different ways, third operation 5 different ways, fourth operation 5 different ways, fifth, sixth, 5, 5. So according to the principle of counting, it's nothing but 5 power 6. It's nothing but 5 power 6 different ways those rings can be worn to the finger. So how do you say this? Let us take another example based on this. How to remember this? Which one? Generally the students get confused. Number of rings, number of fingers. Which one should become in the base? Which one should go to the power? Generally the students will be getting doubt. So always remember, the ring come to the finger, but finger will not go to the ring because it is fixed. It's fixed, understand? It's fixed. So fixed one should always be the base. Fixed one should always be the base, and the variable should be the power. Understand? So 5 power 6. Similarly, I'll give you a suitable example, similar example to this. You have 3 letters in your hand. What are they? 3 letters to be posted, and you have 4 letter boxes, maybe post boxes. These 3 letters are to be posted into 4 letter boxes. Then your common sense says that you have to go to the letter box to post the letter, but post box will not come to you. So understand that. So which one should be the fixed one? The box should be the fixed one, and hence in this case they should be the base. What should be the power? The letters should be the power. It is 4 cube. It's 4 cube, which is nothing but, how do you say this? First letter taken to the post box, and it can be posted in first post box, second post box, or third post box, or fourth post box. So first letter has 4 different ways to be posted. Similarly, second letter also 4 ways to be posted. Similarly, third letter also can be posted in 4 different ways. All these can be performed in one after the other simultaneously according to the principle of counting in 4 into 4 into 4, which is nothing but 4 cube different ways. So if you look at this problem, if you work out the similar models, you'll understand which one should be the base and which one should be the power. The base should always be the fixed one and the power will be the variable. Understand it? Okay. So next question. On a New Year day, every student of a class sends a greeting card to every other student of the class, and the number of cards delivered by the postman are 600. Then find the number of students of the class. It's a little different question. The answer is given, you have to find out the number of students here. So there is you have your classroom, and let us suppose you have in your classroom there are 30 students or 50 students. Then on a New Year day, you have taken a vote that every student must give greeting card to another student. If you are 30 students, then if you consider yourself, then you have to eliminate yourself from the 30. Then how many cards you have to purchase? 29 cards you have to purchase. Are you with me? First, what you have to do, you think about yourself. You have to distribute the greeting card to all the remaining students. So how many greeting cards you have to purchase? If your class is consisting of 30 students, you have to purchase 29 students excluding yourself. Similarly, your friends must also purchase 29. Your third students, whoever is in the class, he has also purchased 29. So how many are there totally? 30 students are there. How many times you have to add this? 30 times. So that means the total number of cards that are to be purchased or posted are 29 into 30. It's a basic understanding about that. So in this case now, I have taken another example just for you to understand in a better way. So now in this question, the number of cards delivered by the postman are given to be 600, and we don't know the number of students there. So let us suppose there are n number of students. In this case, 30 number of students are there, then the number of cards taken are 29 into 30. What are these number of students? Now, because we don't know the number of students here, we have taken it to be n. Then each student has to purchase 29 cards. So n student has to purchase n minus 1 cards. So n into n minus 1 is equal to 600. N into n minus 1 is equal to 600. You can solve it as a quadratic, or you can even adjust it also. You can solve it as a quadratic. But if you see carefully, you have to write this as two consecutive factors. You have to write this as two consecutive factors. What are they? If you write it as 6 into 100, not consecutive, and let us again split it. 6 into 25 into 4. Then 6 into 4 is 24. It is 25 into 24. Understand it carefully. Now, it is nothing but n into n minus 1. What should be n now? 25. So, our answer to this question is n is equal to 25. So, if there are 25 students in the class and every student is posting a greeting card to remaining students, the number of students and if the number of cards posted are 600, the number of students in the class must be 25. So, that is a question. Now, coming to the next question. The letters of the word article. The letters of the word article. Please read that question carefully. Nowadays, the students are avoiding the habit of going through the question and understanding it, because the patience levels are nowadays gone down to the students. So first of all, go through the problem, read it carefully and understand the given concept there, and try to apply what we have learned now. So the letters of the word article are taken 4 at a time and arranged in all possible ways. Find the number of arrangements containing R and not containing E. So what are the letters here? A, R, T, I, C, L, E. Now what we need 4 letter arrangements. Then you may think that, sir, here the question, we have to write the number of arrangements. So arrangements are nothing but permutations. So now we have to apply the permutation formula. Of course, the permutation formula itself is derived from the principle of counting. We can do that using principle of counting also. So what you have to do first of all, you have to fulfill the restriction given. What is the restriction given there? It must contain R and it should not contain E. That means E to be avoided. We are avoiding E now, and R must be there. R must be there. So you have to take this R, and R should be placed either here or here or here or here. So R can be placed in how many different ways? 4 different ways. R is placed now. It's common sense. Sir, without repetition or with repetition? No question at all, because each single letters. You have to take from this only. No question of repetition in this case now. So R can be placed in 4 different ways. That means R may be present anywhere in these 4 blank places. R will be occupying one place. R will be occupying one place. And how many places are remaining? 1, 2, 3. How many letters are remaining? E removed because we don't want. And R already placed. How many places remaining? 3 places. How many alphabets remaining? 1, 2, 3, 4, 5. 5 alphabets are remaining. So first operation is done. What is the first operation? Filling R in any one of the 4 blank places, which can be done in 4 different ways. It's done. Now what about the remaining? A, T, I, C, L. So how many letters are there? 1, 2, 3, 4, 5 are there. So this can be filled in how many different ways? 5 different ways. And this can be filled in how many different ways? 4 different ways. And this can be filled in how many different ways? 3 different ways. Understand it? So what is happening here? We are fulfilling the restriction first, and then we are filling the remaining places. So first operation of filling up of R is done in 4 different ways. Because E is not needed, E removed, and remaining letters 5 are there. This is filled in 5 different ways, and this is filled in 4 different ways because already 1 is filled, and 4 filled, and already 2 are filled, only 3 are remaining. This can be done in 3 different ways. First operation, second operation, third operation. All these operations, one after the other or simultaneously, can be performed in 4 into 5 into 4 into 3 different ways. It is 20 into 12, which is nothing but 240. 240 different ways we can have the 4 letter arrangements that contain R, not containing E. Understand that. So this type of questions also you can answer very easily. Okay. Next, find the sum of the numbers formed by taking all the digits from 1, 3, 5, 7, 9. And you have to go through the question carefully, which is very, 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 very important, and also little tricky. Why you may be attempting such problems. Find the number of numbers that can be formed. It is not find the number of numbers. You have to see that it is a find the sum of the numbers. Sum of the numbers means what? I'll take an example and I'll explain you. Like I have 1, 2, 3 in my hand. I want to form different 3-digit numbers, without repetition. then in this case it is 123, 132, 213, 231, 312, 321. Then you are written this, then what is the use of principle of counting? You may be thinking like that, isn't it? Good. Then in such a case, because a 3-digit number contains 3 places, I am choosing 3 places here, and first blank place can be filled with either of these 3 in 3 different ways, because without repetition we need it. So we can fill this in 2 different ways, because 1 digit is already filled, and this can be filled in 1 different way. So it is 3 into 2 into 1, which is nothing but 6. These 6 are shown to you clearly. You have written them. So here in this case, what happens? You have to understand, you have to find the sum of all this. According to that question, of course, that's a 4-digit. By taking all the digits means it is a 5-digit number. It's a 5-digit number. But for your understanding, I have taken only 3-digit number. You have to find the sum of all this. So from this one, what I want to make you understand, in this case, 1 is in 1's place. The sum contributed by 1 is 1 into 1. In this also 1 into 1. And sum contributed by 2 in this case is 2 into 1. In this case also 2 into 1. The sum contributed by 3 in this case is nothing but 3 into 1. And in this case also it is 3 into 1. So that means if you split the place wise to form the number 123, it should be 1 into 100 plus 2 into 10 plus 3 into 1 will give you 123. Understand that. The number 123 is formed with the contribution of 1, 2, 3, and by placing them in hundreds, tens and ones place. So you can split this number like it is 2 into 10. It is 1 into 100. That's what I have shown it here. 1 into 100 plus 2 into 10 plus 3 into 1 becomes 123. So what you have to understand here, let us do like this first. Let us add all of this. Let us add this. 4, 3, 7, 6. It is, I think it should be 1331. We can count this. So what we do, this 1 is in 1's place in this case, this 1 is in 10's place in this case, this 1 is in 100's place in this case. So we will split it like this. Sum contributed by 1. Sum contributed by 1 will be like, I will do like this. Because it is a 3-digit number, I will place 1 in 1's place and 1 in 10's place and 1 in 100's place. Now, I need the number of numbers that are containing 1 in 1's place. So, how many digits are remaining here? 2 digits are remaining. So, these 2 digits can be filled in 2 different ways. Here it can be filled in 1 different way. So, it is 2 into 1 and 1 is 1 only. That is 2 numbers will contain 1 in 1's place. It's clear. This one, 231, 321. 231, 321. We are applying the principle of counting here. Now, what is the sum contributed here? Now, 2 into 1 into 1 into 1 only. Why 1? 1's place, 1. In this case, also 2, this is 1, this is 1. So, this is 2 into 1 into 1 into, this is 10. Similarly, this is also, you can say 2, 1, 1. This is also 2 into 1 into 1 into 100. If you add this, this is 2 into 1 into, if you add all this, what will be getting? What will you be getting? It is 111. This is the sum contributed by 1. Similarly, sum contributed by 2 will be, similarly, sum contributed by 3 will be if you add all this, then you'll be getting this is 2 into 1 taken common into triple 1 also taken common into the sum of the digits 1 plus 2 plus 3. Okay, this will give you 1331. Similar manner you can solve this problem also. That means here I have given you an example of 3 distant number. You note down the problem and you split it in this way. Some contributed by 1, next some contributed by 3, next some contributed by 5, next some contributed by 7, next some contributed by 9, and add all of them, then your answer must be like this. Your answer will be 66,66,600. You try that one, and without using the permutations, with the use of principle of counting, I have given you this example. You try that one, and in the next class, we will go to the next slide. In the next class, we will derive NPR. P of n comma r is equal to n factorial upon n minus r factorial, and we will understand how the principle of counting is used to derive that permutation formula n factorial by n minus r factorial, and what is with repetition and what is without repetition, and all this will be made into the formula for our convenience. But the principle of counting is very important for workout or to derive any formula.